Welcome to Electric Circuits, Lesson 1. These are examples of what electric circuits looks like in real life. The first thing you have to know about electric circuits is Ohm's law. Ohm discovered that R is equal to V divided by I. What this means is, if you plot volt values against current values, you'll get a straight line which is then R. So, what you should know is R is V divided by I, and this will give you a straight line if you plot V versus I. R is for resistance, and this is measured in ohms, or this funny sign here that you should really know. V is for voltage, and is also called potential difference. This is measured in volts. Current is measured in ampere, which is an A. So I is for current measured in ampere, A. Let's look at some definitions. The definition of voltage is the work energy needed to move electric charge. And then the definition for current is the rate of flow of charge or electrons. You can earn extra marks if you study your definitions. So, if we look at resistors connected in series, the total resistance of the circuit would then be the resistance of resistor 1 plus resistor 2 plus resistor 3. The total voltage or potential of the circuit would then be the reading on voltmeter 1 plus voltmeter 2 plus voltmeter 3. And the current through the circuit is equal to the current through resistor 1, the current through resistor 2, and the current through resistor 3. To make it a bit more simpler, let's look at an example. The current flowing through these three resistors are all the same because they are connected in series. The voltmeter reading, the potential difference of resistor 1 and resistor 2 and resistor 3 would be different. And then you get the total voltage when you add these three together. The total resistance of the circuit would be the resistance of resistor 1 plus resistor 2 plus resistor 3. Okay, let's do a quick example. Two ohmic resistors R1 and R2 are connected in series with a cell with negligible internal resistance. Find the resistance of R2 given that the current flowing through R1 and R2 is 0.25 amperes and that the potential difference across the cell is 1.5 volts. R1 is equal to 1 ohm. Okay, very important. You should be able to derive that the circuit looks something like this. The battery or the potential difference is 1.5 volts. There are two resistors. Resistor 1 is 1 ohm and the current through the circuit is 0.25 amperes. This is all information that you get from the question. Now, what do they ask? They ask, find the resistance of R2. So, you have the resistance of R1. So, you need the total resistance to get R2. You can calculate the total resistance by using Ohm's law. R is V divided by I. The V total you have, that is 1.5 volts. The I total that you have, it is 0.25 amperes. They give it to you in the question. So first you need to calculate the total resistance, and then you have to calculate R2. So, step 1 would be to calculate the total resistance. the total volts in this circuit is 1.5, so you substitute that, and the current flowing through the circuit is 0.25 ampere, so you substitute that, which gives you 6 ohms. So the total resistance is 6 ohms. Step 2. You have that the total resistance is R1 plus R2. You want R2. So the total resistance minus R1 would then give you R2. You just calculated the total resistance, which is 6 ohms. They give you that R1 is 1 ohm, so you can calculate that R2 is equal to 5 ohms. Example 2. In the case of the circuit shown, calculate the potential difference of V1, V2, and V3, which are across the resistors R1, R2, and R3. Okay, so they want V1. You have your Ohm's law, which is R is V divided by I. So R1 is 2 ohms. And I1, which is the current flowing through all 3 resistors, because it's the same current through all of them, is 2 amperes. So V1 would be 2 ohms multiplied by 2 amperes, giving you 4 volts. Then you do exactly the same for R2. R2 is V2 divided by I2. R2 is 6 ohms. You get that from the question. I2 is 2 ohms, which you get from the question. V2 is then 6 ohms multiplied by 2 amperes, which gives you 12 volts. V3 can then be calculated by using the equation for V total. The total voltage in this circuit is given to you, which is 36 volts. This is V1 plus V2 plus V3. We just calculated V1 and V2, so we can solve V3. V3 would then be 36 volts minus 4 volts minus 12 volts, which is then 20 volts. The resistance of R3, which is the second part of this question. R is V3 divided by I3. V3 we just calculated to be 20 volts, and I3 is the same current flowing through all of these resistors, 2 amperes. R3 is then 10 ohms.